Based on the software types, we can consider different types of the architectures. The first is the sequential software architectures, concurrent software architectures, and component-based software architectures. So the sequential software architectures. So actually it's designed for the sequential program. This type of the architectures designed for sequential program. So what the sequential program? Actually, the sequential program is one program. It's a program with only one phase. If you are familiar with Java, maybe when you create a class, this class actually is running sequential. It's only one step. In one step, it's only one thread. In each step, it's only one thread. So, but also in Java, you can use multiple threads. So by doing that, you can actually utilize your process. Since now most of the process is multi-core. So the sequential software architecture actually is only designing for the sequential program, which is the software or the program that implements only one instruction per types. In these programs, we not take the advantage of multi-core process and just implement one structure per type. Actually, the software or the sequential software architectures, it's limited for our topics, which is autonomous system. You cannot use the software or the sequential software architecture in our systems or in our systems type because, as I mentioned, this type it's just implement one page per types. So this type doesn't take the advantage of multi-process or multi-core. So in our systems, actually, we have many threads or many control. So in sequential, actually, you can imagine it's only one control, and this control is control the whole programs or whole systems. But in our systems, actually, we have many inputs, many types of inputs, many type or many different type of input and output device, and based on any of these inputs, the system should run. So as we say, this type of software architecture not suitable for the real-time system. So how we can use this type of software to deal with the the real-time system or the autonomous system. Actually, we can use it by designing a cycle of execution. Cycle that means should have a loop, infinite loop, and this loop is continue running and check all the output and input devices. So in order to deal with concurrent system or real-time system, this type of software architecture, we should have a cycle of execution in which this cycle is loop and check all the input and the output devices. But we still say there is a limitation for these software architectures, so we should go ahead for another type of software architectures. Concurrent software architectures. In contrast to the sequential software architectures, concurrent architectures actually it's multi-thread executions. That's mean in concurrent architectures we have many threads and each thread can execute the process. So in concurrence, we have first is the architecture of the system. There are separate concurrent processes or tasks. So we have multitask in the system, and each task have its own threads that can execute it. So the task, any task have its own thread, and any thread can execute the process, can execute the CPU of the system. So also, unlike the previous sequential architectures, in sequential architecture, actually we have only one active class that can execute the process. But here, each class is can considered as active class, and each class can execute the process. So here is the main difference between these two types. There we have only one thread, and there we have only one page, and this page can execute the process, while the other is other. So only one active thread, and it's only can execute the process. While here we have multi. So based on our task, we have also threads, and any of these threads can execute the process. So for real-time system, actually, it's very effective design to use this type of concurrent task. So because the software architectures can get the input from any device. So each device can be considered as a process or can be considered as a task. Each input device can be considered as a task or as ready to receive the input from any task, any input, and then based on that execute the process. In concurrence, actually, as we say, each device can be considered as input, as events, and then this input can execute the system. Actually, the components in general, it's very important for deploying software architectures. So the components here can be considered any unit informations, can be considered any independent encapsulated of the system. So it can be a process. So in general, the components, it's independent encapsulated unit within the system. So and these components can be central components or composite components. Composite components need multi or many components, many other components. In this type of the software architecture, we consider the system as components. So the components here can be subsystem, can be some informations. So each unit of each unit of the system can be considered as components. And these components actually it's interact with each other, should connect it with each other, and the information should transfer from one components to another components. So each components should communicate with others using an interface. So the components is corresponding to its communicate with each other components using interface. So all the information that needed from one component to another component is contained in the interface, which is separate from the implementations. So here we have in this interface, in this tab of the architectures, we have the internet components, which consider, as we say, any unit of the system. Each components have corresponding interface, and this interface is communicate with other components. So here the components can be considered as black box, since we say the implementation is separate from this from the components. So component-based and concurrent and distributed system. In a distributed system, the system is distributed on different nodes in maybe different places. So how this component phase can work with this type of systems, concurrent system or distributed system. Actually, each component can be considered or can be deployed on one node. So here we have many components, and each component is deployed on one node, and then this node is executed in parallel. So here how we can use a component based on our concurrent and distributed system. And then later, how they can communicate with each other. Actually, they can communicate with us using synchronized or synchronized communication types.